Okay, hello guys, it's Ngati Top Erase. Today we are going to do a bit of quantity estimate. We'll I will learn you how to determine the number of block and the number of mortar needed to build a wall. So that's our target of today. Find the number of blocks and find the quantity of mortar. Okay, to start, we'll have here, we consider a wall of 3 meter high by 4 meter length. So you have a wall of 4 meter length and 3 meter high. And what you have to know to have the number of blocks is that, first of all, you need to know that for a certain type of block, that's, for example, we are studying the case of block 15 by 20 by 40. For 1 meter square of block 15 by 20 by 40, you have 12.5 blocks. So for 1 meter square you have 12.5 blocks. That's the first thing that you have to know. And the second thing now, you have to know, we'll directly go on the computation of the area. We'll directly see how to compute the area, because the base is that to have the quantity of the number of blocks, you just have to find the area of your wall. So to find the area, you have a wall is equal to length times height, which will give you 3 times 4, that's 12 meter square. So to have the number of block now, you will just use the area of your wall, that's 12 meter square times the number of block per meter square. That's, you know that initially you have 1 meter square corresponds to 12.5 block. So you will have exactly 12 times 12.5, that will give you 150 block. So this is the number of blocks needed to build a wall of 3 times 4. But what you have to know is that in the process, to buy the block, and in the manufacture, buy the block and transport it to the site, or even if the block is met on site, you will have to there are certain number of blocks that will be break during the process of working. So you have to consider a majoration, and we always take the majoration to be 5% of majoration. That's like a coefficient of loss. So I noted it, gamma s is equal to 5%. So you add 5% on the number of blocks that you found to build our wall of 3 by 4. That's the final, and you will call that number of block now the final number of block. That's NFB. NFB will be equal to what? To the majoration coefficient times the number of blocks plus the number of block you find. So that's 5% and 150, which is the number of blocks that we found previously, plus 150 now, the number of blocks that we still found previously. It will give you the final number, NFB, which is the final number of blocks, that will be equal to 158 blocks. So to avoid to waste time, I wrote everything and calculated early. So now the second point here was to determine the quantity of mortar. Find the quantity of mortar need to build that 158 block. So to determine the quantity of mortar needed to build that number of 158 blocks, we know that we call VM the volume of mortar here. VM is the volume of mortar, and we will call VBM the volume of block with mortar, and VB the volume of block himself without mortar. So you know, to have the volume of mortar for 1 block, you will do the volume of block with mortar minus the volume of block without mortar, that's VB. So you will do volume of block with mortar minus volume of block without mortar. That's for 1 block. Now when you multiply times the number of block, the final number of block, it will give you what? It will give you 0. That's the computation. You have 0.21. That's when you convert the dimension, because we are working with a block of 15 by 20 by 40. Remember, 20 by 40 by 15 is still the same. So, and we have to consider one thing. We have to consider the thickness of mortar, which is considered as 1 centimeter. When you converted it into meter, it gives you 0.01 meter. So you have to consider the length of the block of 15, that's the height of block of 15, that's 0.2 meter, that's 20 centimeter, plus the 1 centimeter of the mortar times 0.41. 0.41 here corresponds to the length of the block, which is 14, plus the thickness of the mortar, that's 0.01. That's why you have 0.21 times 0.41 times final the width of the block, which is 15. The width of the block here will not be affected by the thickness of mortar. That's why it remains 0.15 here. So you will have this computation and you make it this way minus now the volume. This is the volume of block normally without mortar. So in other words, the volume of block with mortar corresponds just to the volume of the block when we consider the thickness of the mortar, which is in this case 1 centimeter. So that's the volume of one block times the number of block, the final number of block that we need for the work. It will give you what? It will give you 0.15 meter cube. That's 0.15 meter cube. So this is the final volume of mortar needed for the work. So thank you. If you like the video, you leave me a like and comment. Click on the notification symbol and follow me if you are not yet there, so you will learn more about civil engineering. Thank you.